So this lesson is more information about what we talked about in lesson 1.1 regarding intervals. We want to talk about what is finite, what is infinite, what makes them one of those. I wanted to go a little bit farther about that. When we talk about interval types, they can be finite or they can be infinite. Finite always has endpoints. Infinite will have at least one arrow. Finite will be restricted, infinite will be unrestricted. So if you were to graph a finite, it would be a line with some kind of endpoint. It could be open or closed, doesn't matter. Infinite is going to have at least an arrow. Maybe it has an endpoint here. Maybe it has arrows at both ends. Either way, it's going to have at least one arrow to be infinite. Finite is something that is restricted. So for example, time is restricted. You cannot have negative time. Finite is also something that's restricted by what makes sense. Let's say we're talking about how far someone jogs. That's going to be restricted because you can't jog forever for the rest of your life. Infinite is going to be something that's unrestricted or has no end. Space is infinite. It goes on forever. As far as you go, there's always something farther. Time is infinite in one direction. Clearly, you can't go backwards in time. You can't have negative time, but you can go on forever forward in time. So there's kind of a difference between those two. Finite, again, has very obvious ending points or restrictions. Infinite goes on forever in at least one direction. So given all real numbers from -3 to 17, is that finite or is that infinite? If we're talking about a number line, for example, let me just graph this here, and we're talking from -3. No, my hashes are not evenly marked. To 17, if you were to graph this, you would have endpoints. Therefore, this is a finite set of numbers. From -3 to 17 includes an awful lot of numbers, but it doesn't go past that. We're not going higher than 17, we're not going lower than -3. If we were to graph all real numbers less than or equal to 14, this one is going to be infinite. I guess the last one was finite. This one is infinite. Because even though you have no numbers that are higher than 14, you're talking about every single number lower than 14. 13, 12, 11, -2, -7, -1,365,000. There's an infinite amount of numbers or set of numbers that is less than or equal to 14. As you can see, I've got an arrow on the end. That's a really good way to know. Looking at this first red one here, is this finite or infinite? We know that this is finite because it has two endpoints. The blue one definitely has to be infinite. We've got an arrow showing that it's going to go on forever. So again, really easy, just look at the graphs. You can see two endpoints means it's finite, at least one arrow, sometimes two arrows, means that we're talking about something that is infinite. Looking at a graph, it's the same idea. Even though we have two variables, you can see on this first one, I have very clear endpoints. So this first one has to be finite. The second one, I have at least one. In fact, I have two arrows, making this one infinite. I hope you're kind of seeing the difference here, especially endpoints versus arrows. That really kind of tells you whether the graph is finite or infinite, or the interval is finite or infinite. I hope that makes sense for you. Again, if you have questions, let us know.